Today I am going to talk about Gauss-Jordan method. Using Gauss-Jordan method, first I will find matrix inverse and then I will solve system of linear equation. So here are the system of equations. So here 2x plus y minus z is equal to 3, 3x plus 2y plus z is equal to 8, x minus y plus 2z is equal to 1. So then first we have to write the A matrix, and then I will take the unit matrix, identity matrix, and then using reduce row echelon form, and then I will get A become identity matrix and then identity matrix become A inverse. So from that I will get the A inverse, and then I will solve the x is equal to b, means I will get the solution x. So that will be nothing but x, y and z. Now for that, first, so these are the system of equation, and first we have to write the coefficient matrix and then constant matrix. Coefficient matrix, so this is that x coefficient, so 2 3 1, y coefficient and then z coefficient and then constant. And then I'll write augmented matrix setup. So here A matrix and then B matrix and then identity matrix. Now we will do the operation. So if I do the row operation, A become I matrix and then B will be the solution, and then I become A inverse. So I'm going to do that. So for that, so this is my starting matrix. First I'll make this element is pivot element become 1. For that what I have to do, R1 divided by 2. So that is the operation number 1. If I do that, so new R1 will be 2 by 2, 1 by 2, minus 1 by 2, minus 1 by 2, 1 by 2, minus 1 by 2, 3 by 2, 1 by 2, 0 by 2, 0 by 2, and this will be the new R1. 1, half, minus half, 3 by 2, half, 0, 0. Now if I plug this R1, so then my after operation 1, the matrix will be like that: 1, half, minus half, 3 by 2, 1 by 2, 0, 0. Next target is I am going to make this element 0. So for that I am going to do that operation 2. So for that operation 2 is R2 minus 3 by R1. So this is R2 minus 3 into R1. So if I do that operation, so I'll get new R2. So new R2 will be, so R2 is 3 2 1 8 0 1 0 minus 3 into R1. R1 is 1 half, minus half, 3 by 2, half, 0 0. Now if I do the calculation, I'll get new R2 is 0, half, 5 by 2, 7 by 2, 3 minus 3 by 2, 1 and 0. Now if I plug this new R2 in that matrix, so new after operation 2, my new matrix will be like that. So you can see this becomes 0, and obviously other element will change accordingly. Now next target is this element become 0. I am going to make this element become 0. For that I am going to do operation 3. So operation 3 is here. So operation 3 is that R3, because I am going to make this is 0, R3 minus R1. If I do that, this will be 0. So for that new R3 will be R3. So this is R3 and this is R1, and just simply subtract. If I'll get that new R3 0 minus 3 by 2, 5 by 2, minus half, 0 and 1. So now if I plug that new R3, so my matrix will be like that. So then next step is, so I will make this next step, this will be pivot element, and I am going to make this element to 1. So for that I have to multiply 2 into this R2. So if I do that, so that will be the operation 4. So operation 4 is R2, that 2 into R2, and then after getting that pivot, this element and this element I am going to make 0. Okay, so first I am going to do this operation and then I'll do other operation. So first here operation 4, so 2 into R2, so make the pivot 1. So new R2 will be 2 into this R2. So I'll get new R2 is 0 1 5 7 minus 3 2 0. So now if I plug this new R2, so after operation 4 my matrix become like that. So 0, this become 1 5 7 minus 3 2 0. Now next is I want to become I want make this element 0 and I want to make this element 0. So for that I have to go operation 5 and 6. Operation 5 here, so R1 minus half R2, so this will be 0. So if I do that, so new R1 is 1, so this is R1 and this is half into R2. So now if I do that operation, I will get this element, R1 element 1 0 minus 3 minus 2 2 minus 1 0. If I plug that, so new matrix will be, so that will be like that. So if you see here, so this is 0. Okay, so 1 0 minus 3 minus 2 2 minus 1 0 0 1 5 7 minus 3 2 0 0 minus 3 by 2 5 by 2 minus half minus 1 by 2 0 1. I'll get this matrix. Next is I'm going to make this element 0. So for that I'm going to do operation 5. So operation 5 is here. So R3 plus 3 by 2 R2, if I add that, so this element becomes 0. Okay, so for that I'm doing that operation. So after doing that operation, R3 plus 3 by 2 R2, so this 0 0 1 10 10 minus 5 3 1. Now if I plug that R3 after operation 6, I'll get 1 0 minus 3 minus 2 2 minus 1 0 0 1 5 7 minus 3 2 0 0 0 10 10 minus 5 3 1. So now next this will be my pivot element, so that will be 1. Okay, so for that I have to divide with 10. So R3 divided by 10 I have to do. So next operation I am going to do, so means operation 7. So operation 7 here, so 1 by 10 R3, so make pivot 1. So if I do that, so this is 0 by 10 0 0 by 10 0 10 by 10 1 10 by 10 1, then minus 5 by 10 minus half 3 by 10 1 by 10. So if I plug that, so after operation 7, so I'll get 1 0 minus 3 minus 2 2 minus 1 0 0 1 5 7 minus 3 2 0. So now my target is this element and this element become 0. Then I'll get this A matrix become changed to identity matrix, I matrix. So for that I'm going to do operation 8. So operation 8 is here. So R1 plus 3 R3. So I'm going to make this element 0. So for that I have to multiply 3 R3 and then add. So new R1 will be, so this is R1 and then 3 into R3 and then add. So you'll get 1 0 0 1 half minus 1 by 10 3 by 10. So my new matrix will be after operation 8, so that will be 1 0 0 1 half minus 1 by 10 3 by 10. So now you can see this element becomes 0. Now next is this become 0. So then I'll get that I matrix. So for that I'll do operation 9. So here operation 9, that is R2 minus 5 into R3. So R2 minus 5 by 5 into R3. So this element will become 0. So for that if I do the operation, so new R2 will be, so this is R2 and this is 5 into R3 and minus subtract. So then I'll get this element 0 and consecutive, if after doing the operation I'll get that other element will change. So 7 become minus half, minus 3 become 1 by half, minus, then I'll get half. So new R2 will be 0 1 0 2 minus half half and minus 2. Now if I plug after operation 9, so my new matrix will be 1 0 0 0 1 0 0 0 1 and 1 2 1, and I'll get that I matrix become I matrix actually change to another matrix. So that is nothing but A inverse, and this is our solution, and this is nothing but I matrix. Now our solution is x is equal to 1, y is equal to 2 and z is equal to 1. So this is my solution as well as inverse of the matrix. Now after operation 9, so final reduced matrix is this. So this is the I matrix, this is the solution, and this is A inverse. Now if I verify that, so this is my A inverse, and again if I do that, x is equal to A inverse B, because we know that B is nothing but 3, 8, 1. Now A inverse we have, and if I multiply with B, we'll get x is equal to 1, y is equal to 2, and z is equal to 3. Now if you see that, if you multiply 3, 8, 1, so if you multiply this and this, so that will become 1. Then this, sorry, this, and then B matrix. B matrix means 3, 8 and 1. If I do that, we'll get 2. Similarly, this matrix multiplied with this, so we'll get 1. So x will be 1, y will be 2, and z is equal to 1. Now next is I have to verify. If I multiplied A and A inverse, I will get the I. So this is my original A matrix, and this is my A inverse, and then if I multiply, I will get the identity matrix. So now already I have the system of the equation. So if I plug x is equal to 1, y is equal to 2, and z is equal to 1, I will get the left hand side is equal to right hand side. Okay, so all this the equation actually verify with that x is equal to 1, y is equal to 2, and z is equal to 1. So that's it. So once we'll get the A inverse, we got that A inverse, and then solution. So x is equal to 1, y is equal to 2, and z is equal to 1. That's it. Thank you.